Hey folks, welcome back. We've spent a lot of time in this module looking at distributions of data sets and ways that we can summarize and visualize those distributions both for discrete and continuous variables. I want to wrap this section up by looking at some measures of central tendency. Now, we've already talked about several of these measures, and I'm not going to do a lot to really repeat that. But I do want to show you a couple of cool things that you can do in Tableau and ways that you can get some insight into your data based on what you're seeing in some of these distributions. So measures of central tendency, the basic ones that I'm sure you've seen in at least one stat class and probably more, are mean, median, and mode. Mean is just the arithmetic average of the data, and so that's computed by summing up all the values of the data, dividing by your sample size to compute that arithmetic mean. Median, of course, is the value that splits the data set into two equal portions. So 50% of the data lies above the median in value, 50% lies below it. And then, of course, the mode is the most frequently occurring value. Now, this can have slightly different meaning when we're talking about discrete variables versus continuous variables. With discrete variables, because there are a limited number of possible values the variable can take, the mode is going to be the most frequently occurring value. Whereas with a continuous variable, because we break our data into segments or classes, our mode is generally going to be a modal class, or the class that has the highest frequency among the data set. Now, a couple of just other, tidbits about these measures. Every data set, every numeric data set is going to have a mean. Categorical data does not have means. You can't compute an arithmetic average on categories. Every numeric data set is going to have a median. There's going to be some value that divide the higher values from the lower values. And even data sets that have only a single value, as we saw previously, do have a median. It's just the same as all the other values. But interestingly enough, not all data sets are going to have a mode. Most will have at least one mode. Some data sets will have more than one mode. Some data sets will have no modes. The way you would have a data set that does not have a mode is if every value in the data set occurs the same number of times, or if the frequency for every class is exactly the same across all of your possible classes. That's a little unusual. That would be a uniform data set. There is a term for that. But it's a little unusual. Typically, there's going to be a value or a class that occurs more frequently than the others. And sometimes, of course, you will have multiple modes in a data set. And that's really what I want to focus in on in Tableau, is when you have multiple modes and the insight that that can give you into your data set. So for this example, I'm actually going to work with a data set that I pulled from a site called Our World in Data. And this one is showing differences. Let me get up to the top of this website here. Differences in human height. If you want to Google Our World in Data human height, you can get to this. Now, they give a lot of talk about where the data comes from and, of course, things that affect height. They have several different charts that you can look at here, and they actually got a list of all of them, all of those charts that you can look at, and showing height over time, height of men by birth across many different years. And you can see, as we I think all are familiar with, height of human beings has generally been increasing with better hygiene, better nutrition, better medical care. We see height increasing over time, height of adults. And you can, of course, download all of this data and play around with it yourself. So naturally, that's what I chose to do. Now, the way this data is set up, if we take a look at it, I've already done the download, so let me open the data set up. So it's in a CSV file, so I've got it opened up in Excel. What we have in this data set is we have got data that is broken down. We have a mean height for men, for males, and a mean height for females from several different countries measured over several different years. So we're starting out here, we've got Afghanistan, and we're starting in 1896 with Afghanistan. And we go for our average heights for Afghanistan all the way through, looks like we go through 1996, then we skip a bunch, and then we have 2015. Then we do the same thing for Albania. Start in 1896, and we have several different years and several different values. These heights are measured in centimeters here. And so we've got a lot of data. If I go all the way down to the end, the bottom of this data set, you can see we've got about 5,400 rows of data. All right, going, oops, actually more than that, go further, about 21,000 rows of data when we get all the way down to Zimbabwe. So about 21,000 rows of data. Most of it is, I think, in the range 1896 through 1996, but then a few 2015 values, or at least 2015 rows tossed in there as well. All right, so that's the data set. Now, what I'm going to do is close this and bring it into Tableau and see a few things that we can do with it. So I want to connect to a text file, and here is my mean height women CSV file, so I'll go ahead and open that up and bring it in. Now, remember some of the things we talked about when we talked about tidy data. What I've got here is I've got two different columns that represent heights. One height for men, one height for women. And in order to efficiently use this data in Tableau, what I'd like to do is reshape it. So I have one column that represents height and another column that represents gender. So remember how to do that. I will select those two columns and then I will pivot. Okay, and so what that will do is that will give me one column called Pivot Field Names that contains the names of the fields that I just chose to pivot. So mean female height, mean male height, and those two values get repeated. And then one column that contains my pivot field values. So here's the, for 2015 in this country in Asia, I'm not going to attempt to pronounce that country. We actually have null values there, but let's go down to Afghanistan. So for 1896, I have the male height here and the average female height here. Right, so I've got my data just reorganized. Now I'm going to rename pivot field values. So that is now called height. And then for pivot field names, let's see what we get if we split that data. So I'll go ahead and split it. And notice that what Tableau has done is it's looked at that text string and it's sort of figured out what's different in those values. And it kind of has recognized that the values that change in those pivot field names is what I'm really interested in. So it's given me my male and female values here. And I'm going to go ahead and rename this. I'll call it gender. All right, so all I've done is taken the data and just reorganized it, reshaped it. Okay, so with that done, let's go ahead and create a worksheet. And what I want to do is start with a histogram of height. So I'll select my variable, select show me, and create a histogram. And let's go ahead and take a look at this. Let me get myself a little more room to work here. Take a look at this. And I can see I do have one null value. If I select on that little null symbol down at the bottom, what I can do is just choose to filter that out. So I'll do that. So I'll filter out my null value. And then let's take a look at our histogram of height here. And you'll notice, yeah, as we're looking at it, looks relatively symmetrical, but kind of lumpy looking. All right, that's not really a technical term, but I think it's sort of a very descriptive term. We can, of course, play around with our bin widths. Remember, we did that with our histogram before. So we can go in and edit our bin widths. The automatic bin width is 0.57, and of course, we're working in centimeters. So maybe I could try 0.5. that gives me a slightly finer grained looking histogram. If I were to go with a bin width of 1 centimeter, all right, that kind of smooths things out a little bit. All right, I'm going to go ahead and just hit undo and go back to the 0.5 centimeter though. But as we're looking at this, again, looking at this distribution, if the mean of the distribution, well, the median of the distribution is probably in here somewhere around 162, 162 and a half centimeters. You know, maybe 163, but somewhere in this ballpark that I have my mouse over now is probably about the median of the distribution. So, you know, half the values below, half the values above. And, you know, looking at it, I would say that the mean is probably a little bit under the median. This data looks to have a tail going off to the left. The modal category is very obvious. It's 159 centimeters. That's the category that occurs most often. But as we look at the data, we kind of see multiple peaks in the data. And at least I see multiple peaks. I hope you do too. We definitely have a peak here where our modal category occurs. And that we do have a single mode. But the other thing that I observe in the data is notice that we have kind of a peak here in the 162 to 165 range, and we have another sort of discrete looking peak down here around 167 up to about 169. So when you see multiple peaks in your data set like this, that is generally indicating to you, well, one possibility that is indicating to you is that you may have multiple overlapping groups in the data set. Now, in this particular case, I know for a fact that I have multiple overlapping groups because I just combined the heights of men and women. I combined them so I could get both men and women's heights on a single histogram here. But watch what happens when I bring gender and let's say drop it into color. Then it becomes very obvious. Yes, we have two separate groups here that have differently distributed data. I see a histogram for the men, right, here showing up in orange. Looks like the modal category for men is 168.5 centimeters. So that's what's giving me this peak over here. And then over here where I've got my overall mode, that's occurring at 159 centimeters. We have quite a lot of women at that height. And then we have a fair number of men as well. And then we're getting this kind of middle hump in the data where our men and women's heights are overlapping extensively. Now, just bringing in that color starts to show me that we have, really two different groups, as we know we did. But then changing the type of graph can also give us a better look at the data. Once we've figured out we've really got different groups here, then if we've got these sort of stacked bar histograms as we see them here, we can really only see the shape of one of the two distributions. In this case, it's the shape of the male distribution. The shape of the female distribution is getting distorted because some of the bars are stacked on top of the male bars, right? So the blue bars are stacked on top of the orange bars. If I'd like to break those apart and actually get each distribution showing up separately on the same graph, then what I can do is go over to my chart type and go from automatic to a line chart. And then the shapes of these distributions, what's really going on with the data, jumps out at you, and becomes glaringly obvious. We have two overlapping distributions of what are really, two different very significant subgroups in the data. And so we see that, the women's heights, where we've got our modal category, looks like the modal category is actually 159 centimeters. We've got a count of 1,069 country year combinations there that happen to occur at 159 centimeters. Very, very slightly followed by 158 centimeters as the next highest value. and then 158.5 also occurring, right? So we've got a very strong peak in our women's measurements right here. So that's definitely the modal categories for the women there. And then for the men, the mode for the men is occurring at 168.5. And so those were where we were getting our two noticeable peaks, as well as a peak here in the middle where the data was combining. So, moral of the story. Now, what I did here, again, think back, big picture, I downloaded data sets, I reshaped the data to give me one variable that contained gender and one variable that contained height, and then created a histogram with both of them together. And not unsurprisingly, what we saw in that histogram was overlapping data, right? But kind of the giveaway that I'm hoping that you'll see, and you'll sort of be looking for this pattern as you're looking for other looking at other distributions, is when you've got multiple peaks like this. Even if you don't know ahead of time, like we did in this case, that I've combined together heights for men and women, combined together heights for two subgroups that have different characteristics. Seeing this kind of multimodal distribution like we're kind of starting to see here is a giveaway that maybe you should look for some significant subgroups. So mode, even though almost tends to be sort of a throwaway measure sometimes when we're talking about measures of central tendency, mean, median, and oh, by the way, there's this mode too. If you can kind of understand what this graph is showing you, it can give you some suggestions on what you might want to be looking for. So I'm going to go ahead and stop this video here, leave you with this one, and suggest if you really want to play around with some cool data, download this and see if you can't recreate some of the cool charts in our world in data. All right, that'll wrap up our discussion of distributions. And of course, as always, if you have questions, give me a shout. I'll be very happy to talk with you. So long.